Hello everyone, for today's lecture we are going to see the induction motor as generalized transformer. So basically before going to this point, as we know that induction motor works on a AC system as well as transformer works on AC system. Okay, so we are going to focus for this lecture the similarities between this induction motor as well as the transformer. So the title is given as induction motor as a generalized transformer. Okay, the generalized means a general transformer, a common transformer. Okay, so for this lecture we are going to see the similarities between this induction motor as well as the transformer, or the similarities in between the induction motor and the transformer. So again for this, so here, as we know that for transformer, this is we have two windings. We call the primary winding, secondary winding. There are two sides. So this is nothing but the transformer core. Okay. So as we studied in the previous semester, this is regarding the single phase transformer. So I have connected the primary winding here. That is as shown by the cursor, by shown by the red color. So this primary winding I have wound on this particularly this name of the transformer core. So again I get I'm wanting the primary winding to this side. I connected the secondary winding to this side. So this particularly this transformer, it is nothing but a general structure of the transformer. This is nothing but a transformer core, and here I connected the primary winding, I connected the secondary winding here. So primary winding has a number of turns as NP. This N indicates turns and P indicates primary, as well as the secondary winding has NS turn, that is S indicates the secondary winding and indicates the turns. So here now this is the primary winding, this is a secondary winding, and this is the transformer core. So when I connect the AC system to this primary winding of transformer, then the primary current IP, that is a P, that is meant primary, I for current. So when I connect the AC single phase or three phase AC system to this particular transformer, so this primary current will flow through the primary winding of transformer, that is a current flowing through the primary winding of transformer. Okay, म्हणजे जेव्हा आपण काय करतो इथं प्रायमरी वाइंडिंगला मी सप्लाय कनेक्ट केलेला आहे. सो जस्ट when I give the supply to this primary winding, the current will start to flow through this primary winding. So because of this current, as we know that whenever there is any current flows in any conductor, so along with this EMF, or we call it, so sorry, along with this magnetic flux will be created. So whatever the flux is created in the primary winding, it is now transferred to the secondary winding, because this is nothing but a transformer core. Now the transformer core has made up of magnetic material, which as we know that it is made up of silicon steel material. Okay, so silicon steel material, or simply we call it as a magnetic material, has a very low reluctance path. Reluctance means opposition to flux. So this transformer core, or this particular, it is made up of very low reluctance path or very negligible reluctance path. So whatever the primary fluxes are created in the primary winding, now it is started to flow through the magnetic core, we call it a transformer core, towards the secondary winding. That means whatever the flux which is produced by the primary winding, now it is now circulated, it is now transferred to the secondary winding of transformer through this particularly transformer core. Now this particularly flux we call magnetic flux are now interlinked, are going to interlink with the secondary winding here. Okay, now due to the flux linkages, as we know that Faraday's first law, whenever the conductor cuts the flux, EMF is induced. So here this particularly conductor, this is nothing but a secondary winding is acting as a conductor, and the flux is nothing but this primary flux. Now here in this case the flux is now movable, but the conductor is stationary. So in that case, so EMF is induced in the secondary winding. Now I suppose I connect one voltmeter at the secondary end of transformer, so I will get the secondary voltage Vs, that is secondary voltage. Now when I connect the load here, then the secondary current will flow through the secondary winding. Okay, this is nothing but a generalized transformer, that is nothing but a transformer ratio transformation system. That means here we have the transformer core, we have the primary winding, we have secondary winding. Now in the primary side, this is primary winding I have connected. When I give the supply, then obviously current will flow through this particular primary winding. Now this, because of this primary winding, it will primary winding current, the primary winding current produces the flux. Now it is flux is produced in the particular transformer core, and this particular transformer core flux is linked, or we call it circulated or flows through the secondary winding. Now according to Faraday's first law, the EMF is induced in secondary winding, so EMF we are getting in the secondary side of transformer. So as compared with the transformer, we are comparing now induction motor. So as we know, induction motor, it has again two parts, stator, rotor. This is again as said earlier, the stator indicates stationary part while rotor indicates rotating part. So here compared to transformer, transformer has a primary winding, secondary winding. Induction motor has stator, rotor. Okay. So as I said earlier, we are giving supply to here the primary winding of transformer here. Okay. So but in case of induction motor, we are giving supply to the stator. That means we are going to similarize induction motor and transformer. That means in the transformer it is primary winding. That means we are giving supply to primary winding. But in the induction motor, we are giving supply to stator winding. So we are considering the primary winding of transformer is equal to the stator winding of induction motor. Okay, what I said, the primary winding of transformer, it is equal to the it is equal to the stator winding of induction motor. हे असं का केलंय किंवा what is the reason? Because here for the transformer I am giving supply to primary winding. Okay, now when I give supply to primary winding, then the flux will be created in the primary one. There is a flux will be created. Now in this induction motor, I am giving supply to stator. Here I am giving supply to primary, but in the induction motor, I am giving supply to stator winding. And as the stator current will flow, now because of stator current, stator winding current, obviously the flux is created in the this particularly stator winding. Okay. Now flux is created in the stator winding. Similarly, in the transformer, the flux is created by the primary winding. Similar to the this induction motor, the flux is created by the stator winding. Okay. So, as in case of transformer, now whatever the flux is created by the primary winding, it is now flows towards the secondary through this magnetic core. We call it a magnetic core. We simply call it transformer core. But here in the induction motor, whatever the flux which is created by the stator winding of induction motor, it is now transferred to rotor. It is flows towards the rotor through the air gap. Here air gap is present in between stator and rotor. Okay, because rotor we are inserting in the stator winding, but in the transformer there is a magnetic flux will flow, or we call it as a magnetic coupler, or simply called as the path for the magnetic flux is nothing but a magnetic core or transformer core. Here whatever the flux which is produced in the primary winding is now it is passed or which is cut or which is flows towards the secondary winding through this transformer core. But in case of induction motor, whatever the flux which is created by the stator winding of induction motor, it is now transferred to rotor through this air gap. Okay, that means here similarly again, the primary, as I said earlier, primary winding is equals to stator. Now this particular transformer core, it is nothing but a media of flux passes. Okay, now whatever the flux which is created in the primary, it is now set, or we call it is now sent, or simply called a pass to the secondary winding through the magnetic, we call it through the transformer core. So here transformer core is act as a that it is nothing but a carrier of the flux, or simply flux carrier. म्हणजे हा काय करतोय, हा फ्लक्स इथून इथपर्यंत येतो, म्हणजे फ्लक्सला फ्लो करतोय. But in case of the induction motor, now whatever the flux which is produced by the stator winding, now it is transferred to rotor through the air gap. So this air gap, it is equal to this transformer core, because here in the transformer core, here in case of transformer, the transformer core which is used to send the primary fluxes toward the secondary. But in case of the induction motor, here the air gap, it is used to provide the stator flux, which is used to supply the stator flux towards the rotor. Okay, now again here, now for this particularly, this transformer has the secondary side. That means this whatever the flux which is created by the primary winding, it is now circulated through the transformer core. It is passed through transformer core. Now it is going to link with the secondary side. Okay, now here the secondary winding of transformer, it is equivalent to rotor winding, because here whatever the flux which is created by the stator winding of induction motor, now it is transferred to rotor through the air gap. Okay, now as we know that rotor is nothing but a rotating part, so it is nothing but we have in case of slip ring induction motor, in case of squirrel cage induction motor, so this is squirrel cage induction motor. So in case of squirrel cage induction motor, this is nothing but a rotor bars which is a squirrel, or we call a squirrel, this particular squirrel structure, or at this called a solid structure. But in case of slippery induction motor, in the rotor side as well, in the rotor side we are providing the rotor winding, okay, in the slippery. But squirrel cage induction motor doesn't have any rotor winding, but slippery induction motor, it has always a rotor winding in the rotor circuit. So here, as compared to transformer, the secondary winding here, secondary winding, what this secondary winding does, now secondary winding is, now it is used to cut the flux, cut the flux of primary side. Okay, secondary winding इथं काय करणार आहे केस, in case of transformer, what is the function of secondary winding? Whatever the flux which is created by the transformer primary winding through the transformer core, now this secondary winding cut this particular primary flux. Okay, हा secondary winding primary flux cut करणार आहे in case of transformer. But in case of motor, the rotor winding of the induction motor is cut the stator flux. Similar to that of transformer secondary winding, the flux is cut by the secondary winding. Now here the whatever the flux which is created by stator, it is now going to cut by the rotor winding. म्हणजे इथं ट्रान्सफॉर्मर मध्ये काय होतं, सेकंडरी वाइंडिंग तुमचा प्रायमरीचा फ्लक्स कट करत होता. बट इन केस ऑफ इंडक्शन मोटर, तुमचा इथं रोटर वाइंडिंग तुमचा प्रायमरीचा फ्लक्स कट करणार, स्टेटर वाइंडिंगचा फ्लक्स कट करणार. ओके, सो ऍज कम्पेअर टू induction motor as well as the transformer, both device working as a similar principle, that is a Faraday's law of electromagnetic induction. That means here for transformer, now according to the Faraday's law, whatever the EMF which is, whatever the flux which is produced by the primary winding, it is now circulated towards the secondary winding. Now according to Faraday's first law, EMF is induced in the secondary winding of transformer. Similarly, for induction motor, whenever we are giving supply to stator winding of induction motor, now flux is created in the stator winding, because when we give supply to stator winding, the stator current will flow through the stator winding, and because of this stator current, flux is produced in the stator winding. Okay, now this flux is, whatever the flux which is produced by the stator winding, this flux is cut by the rotor circuit in the case of motor. But in case of transformer, whatever the flux which is created by the primary winding is cut by the secondary side. ओके, इथं फ्लक्स जो कट होणार आहे तो सेकंडरी कट करणार आहे, आणि इथं इंडक्शन मोटर मध्ये जो काही इथं स्टेटर मध्ये जो फ्लक्स कट तयार होणार आहे, जो स्टेटर मध्ये फ्लक्स जो क्रिएट होणार आहे, तो फ्लक्स माझा रोटर कट करणार. ओके, similar to that of transformer. Okay, so as we compare to both these devices, now I simply call as this primary winding of the transformer, it is equivalent to the stator winding of transformer, because we are giving supply to primary winding in case of transformer, and we are giving supply to stator winding in case of motor. Okay, as well as the primary winding produces the flux in case of transformer, while in the induction motor the stator winding produces the flux. Okay, now here whatever the flux which is produced by the primary winding of transformer, it is now circulated, it is now flows through this transformer core. Transformer core has a very low reluctance path. Okay, so very very less negligible, or obviously called as a negligible opposition to the flow of fluxes, or there is no there is very less reluctance path we are providing by the transformer core. But in case of the induction motor, the air gap which is used to pass the stator flux to rotor. So in case of transformer, the secondary winding which is nothing but, which secondary winding has a number of twists called a secondary winding. Now this secondary winding cuts the primary flux, while in the induction motor, this secondary winding, this nothing but a rotor winding, is cut the stator fluxes. So as I said in the in the case of transformer, by using Faraday's first law, the EMF is induced in the transformer. Okay, secondary side of transformer, because as we know that whenever the current, whenever the conductor cuts the flux, EMF is induced. And now because of this Faraday's law, I get secondary voltage. And suppose I connect one load here, suppose I connected one load here, then obviously the secondary current will flow through this particular side. Okay, secondary side of transformer. But here rotor, okay, rotor is nothing but, this is nothing but a metallic part, this is nothing but a solid structure. Okay, in case of slip ring motor there is a winding, but in case of squirrel cage motor this is nothing but a metallic part which is short circuited by this particular end rings. So in the rotor winding, in the case of induction motor, this rotor acts as a short circuited secondary of transformer. This rotor acts as a, so here suppose I short circuited this part, now it is similar to that of rotor of induction. So here this particularly, if I short circuited the secondary side of transformer, then here this particular structure, it is similar to that of rotor, because in the squirrel cage rotor we are short circuiting the secondary side of transformer, sorry, secondary side of induction motor with this end rings or this end bar. This is end bar, this is end ring, or simply end bar. So this is nothing but a rotor conductor, and we call the rotor bars. Okay, so here it is the figure which is nothing but equivalent circuit of transformer, as we seen in the previous semesters. So this is nothing but equivalent circuit of the transformer. So here when I apply to the voltage V1 to the primary side of transformer, then obviously the primary current will flow through the circuit. So this particularly, this R1 indicates the resistance of primary winding, while the X1 indicates the reactance of primary winding. Again, this is nothing but a primary winding, this is again the transformer core, again this is nothing but a secondary winding. So this R1 indicates resistance of primary winding, X1 indicates reactance of primary winding, while this R2 indicates the resistance of secondary winding, while X2 indicates the reactance of secondary winding. Again this V2, this now again similarly V1, which is nothing but an applied voltage, while E1, E indicates induced. Okay, this V1, it is nothing but applied voltage, while this E1, it is nothing but an induced EMF across the primary side of transformer. Okay, and then similarly here E2, it is nothing but an induced secondary voltage, or called as a secondary, just two indicates secondary induced voltage, while one indicates primary induced voltage, and E2 secondary induced voltage. Now here V2. So whatever, suppose I applied here V1, so this R1 X1 as well as this term. Now here R0 X0, that means this R0, it is nothing but a no load resistance or no load equivalent resistance of transformer, while X0, it is nothing but an no load equivalent reactance. Okay, R0 indicates no load resistance, X0 indicates the no load reactance. And again IW, IM, as we shown, as we seen in the previous semesters. So IW indicates the working component of current, while this IM indicates the magnetizing component of current. Okay, and this I2, actually it is required I2 dash, or simply called as I0 here. I0 is nothing but a no load current of transformer. Okay, how we are drawing this particularly figure? So as we seen in the open short circuit test and open circuit, we call the OC and SC test of transformer. Okay, open circuit test and short circuit test is आपल्याला previous semester झालेला आहे. By according to that data, we can easily draw this particular equivalent circuit of transformer. Okay, हे कुठून आलंय, हे कसं आलंय, तर आपण लास्ट सेमिस्टरला इथं as we seen in the open circuit and short circuit test in the practical session, so in that case we have already found this value. That means this, whenever as in the open circuit test, now we are keeping secondary side open. Okay, while in short circuit case we are short circuiting secondary side of transformer. So when in case of open circuit test, when I open the secondary side of transformer, then in the primary side of transformer I am giving the full rated voltage, that means 230 volt. In that case, whatever the current which is flows through the primary side of transformer, as the secondary side is open, now it is called as a I0, that is a no load current, because we have not connected load to secondary side. Now this current is called as a no load current, we called I0. Okay, now for that particular no load condition, this R0 indicates no load resistance, and this X0 indicates no load reactance. Okay, now again this IW, that means working component of current, that is a working component IW, and this M indicates magnetizing component. This IM, actually it is used to produce the flux IM, while this IW, which is used to supply this resistive losses in the transformer winding, because transformer मध्ये जे वाइंडिंगचा जो काही रेजिस्टन्स आहे तो रेजिस्टन्स जे काय तुमचा रेजिस्टन्स आय स्क्वेअर आर ना पॉवर लॉस होणार आहे. ओके, सो दॅट पर्टिक्युलर आर झिरो इट इज दिस आय डब्ल्यू इट इज यूज टू सप्लाय द लॉसेस इन द ट्रान्सफॉर्मर while this IM it is used to produce the flux in the primary winding. ओके, समजा तुमचा रेजिस्टन्स जर इथं म्हणजे सपोज तुमचा नो लोड करंट as I said in practical sessions. So whenever there is a no load in the secondary side of transformer, then the current is we call it the no load current. Okay, so इथं लोडच नाही आहे, so we call it no load current. So no load current असेल, so suppose when there is a no any resistance in the primary, we call the ideal conditions, or we call it simple called a conductivity state. When there is a no load, when there is no any resistance in the primary winding, so whatever the current which is taken by the primary circuit, it is only used to produce the flux. Okay, but in real case or in simple practical case it is not possible, because uh, ideal case we call there is no resistance is zero, but in practical case resistance is always present, even though it is very small, but we should consider this resistance. Okay, so whatever the current, that is suppose the current is near about current is suppose for example suppose we are current taking current is 1 ampere for example. No, 1 ampere already is too much higher, so we are just consider no load current is 1 ampere. So particularly this 0.9 ampere, that means 0.9 ampere current is used to produce the flux, but 0.1 ampere इथं 0.1 ampere current इथं जाणार आहे, कशासाठी लॉस साठी जाणार आहे. दॅट मीन्स सपोज मी इथे जर 1 अँपिअर करंट जर माझा नो लोडचा इथं फ्लो होत असेल, तर त्यातला 1 अँपिअर पैकी इथं माझा 0.9 अँपिअर करंट 0.9 अँपिअर करंट इथं फ्लो होईल. हा इथं फ्लो होईल म्हणजे काय, ते 0.1 अँपिअरच्या 0.9 अँपिअर इतका करंट इथं म्हणजे फ्लक्स प्रोड्यूस करेल, आणि राहिलेला जो काही 0.1 अँपिअर करंट आहे तो ट्रान्सफॉर्मरच्या प्रायमरी मध्ये लॉस क्रिएट करणार किंवा लॉस साठी उपयोग होणार. तर ट्रान्सफॉर्मर मध्ये माझ्या कुठल्याही प्रकारचे लॉसेस नसतील, रेजिस्टन्स लॉस जर पूर्ण नसेल किंवा जर कॉपर लॉस पूर्ण शून्य असेल, तर जो काही इथला करंट आहे, जो प्रायमरी करंट आहे, हा सगळ्याच्या सगळा करंट माझा इथं फ्लक्स तयार करण्यासाठी वापरला गेला असता. But in practical case, resistance is always present. So whatever the primary current, it is now divided into two parts. Okay. Now similarly, here E1 indicates the induced EMF in the primary side of transformer, while E2 म्हणजे इथं आता V1 अप्लाय केला, इथं आता व्होल्टेज इथं E1 तयार झाला, as shown in this particular figure. When I apply to the voltage here, now इथं काय होईल, करंट फ्लो, आणि इथं I induced EMF first it is produced in the primary side of transformer. Again this E2 म्हणजे काय, हा सेकंडरी इंड्यूस्ड EMF. सेकंडरी इंड्यूस्ड EMF कुठे तयार होणार आहे, तर इथे तयार होणार आहे. जेव्हा हा फ्लक्स, जेव्हा सेकंडरी कंडक्टर जेव्हा माझा फ्लक्स कट करेल प्रायमरी साइडचा, ऑब्वियसली अकॉर्डिंग टू फॅरेडेज फर्स्ट लॉ, नाउ EMF is induced whenever the conductor, this conductor cuts the flux, obviously EMF is induced, and that EMF induced we called as the secondary induced EMF, this E2. Okay, again इथं E2 तयार झालेला आहे. E2 तयार झाल्यानंतर हा काय करेल, E2 आता समजा मी इथं जर लोड जोडला, इथे मी समजा मी लोड असा कनेक्ट केला असेल, काहीतरी लोड कनेक्ट केला, तर ह्या सेकंडरी मधनं करंट फ्लो होईल, म्हणजे इथे E2 तयार होईल. नाव हिअर E2 is produced in the secondary side of transformer. Now it is flows towards the load. So again this R2 indicates resistance of secondary winding, while the X2 indicates reactance of secondary winding. And this V2, it is nothing but it's a terminal voltage across the load, or it's nothing but a load a terminal voltage, because V जे इथे E2 म्हणजे इथे जे E2 आहे इंड्यूस्ड EMF हे डिफरंट आहे, आणि V2 हे वेगळं आहे. म्हणजे इथं जे काही इथं व्होल्टेज मला इथं मिळणार आहे, इट इज द व्होल्टेज विच इज अप्लाइड अक्रॉस, विच इज अवेलेबल अक्रॉस द लोड of the transformer, we called as a voltage, or this particular called as a load voltage. Now general practice मध्ये कसं असतं की this V2 is always less than E2. This V2 is always less than E2, or simply we called as this E2 is always greater than V2. E2 is always greater than V2. का, तर whenever it's here induced EMF E2 is there, now current is flow, this I2 current will flow through this. Now इथं काय होणार, करंट फ्लो होताना काहीतरी ड्रॉप होणार ना, व्होल्टेज I into R, IR ड्रॉप, ओहम्स लॉने इथं व्होल्टेज ड्रॉप होणार. इथं व्होल्टेज ड्रॉप दिला म्हणजे काय, समजा इथं E2 समजा माझं 220 व्होल्ट आहे. ओके, जस्ट अज्युम दॅट 220 व्होल्ट इथं असेल, तर माझा 1 व्होल्ट इथं जाणार आहे बिकॉज ऑफ ओम्स. दॅट इज इथं जस्ट 1 व्होल्ट मे बी ड्रॉप्स हिअर. सो मला इथे किती मिळणार, 219 व्होल्ट मिळणार आहे V2 मध्ये. 1 व्होल्ट कुठे गेला, तर इथं ड्रॉप झाला because of resistance. If the secondary winding has no any resistances, so whatever the E2, that is a 220 volt, I get here, that is E2 is equals to V2. कधी, जेव्हा इथं काही रेजिस्टन्स नसेल किंवा रेजिस्टन्स खूप कमी असेल तेव्हा. ओके, सिमिलरली in case of the induction motor, again this is nothing but an V1 I applied across here primary side of the this particularly induction motor. The primary, that means stator winding. Again, stator winding has R1 resistance 1. Stator winding has resistance we called as R1 and reactance of X1, similar to here. Primary मध्ये जसा R1 and X1 होता, similarly for this induction motor, again stator winding has R1 while R1 is a resistance and X1 is a reactance. Again here R0 X0, that means no load resistance of the induction motor, or simple no load resistance of primary side of induction motor, stator winding of induction motor. So again this X0 indicates no load reactance of induction motor. Now while here ट्रान्सफॉर्मर मध्ये काय होतं, इथं तुमचा मध्ये एअर गॅप होता येतो. ओके, हा एअर गॅप इथनं फ्लो होत होता. पण इंडक्शन मोटर मध्ये सॉरी ट्रान्सफॉर्मर एअर गॅप नाही, सॉरी ट्रान्सफॉर्मर तुमचा आहे काय, तुमच्या ट्रान्सफॉर्मर मध्ये जो का तुमचा इथं आहे, ट्रान्सफॉर्मर मध्ये जो का फ्लक्स तयार होणार प्रायमरी मध्ये, हा तुमचा फ्लक्स हा पर्टिक्युलरली ट्रान्सफॉर्मरच्या कोर मधनं फ्लो होतो ना सेकंडरीकडे. ओके, सो आय शोन इन इथं वॉट एव्हर द फ्लक्स विच इज प्रोड्यूस्ड बाय द प्रायमरी वाइंडिंग, इट इज ट्रान्सफर्ड टू सेकंडरी थ्रू दिस ट्रान्सफॉर्मर कोर. But in case of induction motor, whatever the flux which is created by the stator winding, now it is flows towards the rotor through this air gap. Okay, instead of transformer core, here we have air gap. That means stator flux is passed to the rotor through the air gap of induction motor. So similarly, again this R2 indicates the rotor resistance. Again X2R, that is X2, that is nothing but it's a rotor reactance. As the induction motor has a rotor which is nothing but rotor rotating, always rotor is rotating part. So as we consider this machine is running condition, this X2R, that is equals to S into X2. This S indicates the sleep. Okay, X2 means standstill reactance of rotor, but we consider this X2R, that means this R, that means running condition, R running condition reactance is equals to S slip into X2. Okay, here the primary, as we know, the primary is nothing but a stator, that is a stationary part, while the here secondary, it is nothing but a rotating part. That is, in the transformer, as we case in the previous structure, in the transformer there is no rotating part, only both primary as well as secondary winding is stationary. But in case of induction motor, here the stator winding we call a primary, we simple call a stator winding, it always stationary, but here secondary, that is rotor winding, is always rotating. Okay, so this rotating secondary, that means here secondary is rotating. So this again, this E2R, that is the induced EMF in running condition. Here E2, that means induced EMF of transformer. Here E2, that means induced EMF in running condition, that is rotor, is equals to S into E2, that means slip into it, as we seen in the previous some examples or previous some sessions, previous lectures. So whenever there is the running condition is there, always we are considering the slip. This E2 means it's a standstill rotor reactor. म्हणजे रोटर जेव्हा स्टेशनरी आहे तेव्हाचा जो काय रोटरचा EMF असेल, induced EMF, I called E2. But whenever the rotor is now rotating, sorry, whenever the rotor is rotating, obviously we consider the slip. So we are taking E2R, that is equals to S into E2. Here X2R is equals to S into X2. Okay. So this is nothing but this is the equivalent circuit of induction motor as compared to the equivalent circuit of transformer. Transformer has again R1 X1. Similarly here R1 X1. This is stator winding here, and here the primary winding. Again this part. This part is nothing but a no load component of primary winding or no load component of this transformer, while this part is nothing but a no load component of induction motor. Again here This is the nothing but a transformer core which is used to pass the primary flux to secondary flux, while this is nothing but a air gap which is used to provide, which is used to pass the stator flux towards the rotor. Again here E2 is nothing but a induced EMF in the secondary side of transformer, while this E2R is nothing but S into E2. That means the rotor induced EMF is equals to slip into E2. Similarly R2X2, here again R2 there is a rotor resistance and X2R that is a rotor reactance.